I hope all of you are doing very well. So the weather was pleasant yesterday, but today it might not be. So expect some turbulence. So hold on tight, sit back. The seat belt sign is on. Just follow my instructions and you will be safe. That's all. You will have an adventurous ride. It's going to be a little bit bumpy, but don't worry, we are going to make it through and you'll all be safe if you just follow my instructions. And if you don't, you will be probably like this guy out here. You'll be like this guy out here. So sit back, relax, put your seat belt and you will be fine. Just follow my instructions. Welcome aboard, everyone. How is everybody? How is everybody? Let me know. Hi Anush, hi Chini, hi Kirito, hi Deepak, hi Gaurav, hi Sankar, hi Diya, hi Devi, hi Sonal. Welcome, welcome Abhishek, Deepak, Rajat, Anush, Rishabh. Welcome aboard, everyone. Welcome Devarsh. Well, Pandu is fine, Devarsh. Venu, I'm very good. Hi Piano. Welcome, welcome, welcome. Hi Vikash, hi Asan. Hello Ram, hello Sania. Welcome aboard. So you guys are rocking, it seems. Kya baat hai? Amazing, amazing. Nice to know. Nice to know. So I hope you have attended the session in the morning as well, where I have discussed the previous sessions questions, the drill questions. The drills are the assignments which we give you at Enthuse, and we also discuss it. It's not that we just give you the solutions in a form of a PDF and you are supposed to figure out by yourself. No, we give you the answers, guys. We discuss those questions. That's what it is. And welcome aboard, everyone. So my name is Shreyas. I'm a master teacher at Vedantu for physics, and I conduct all the live classes at Enthuse. Welcome aboard this channel. And like many of you know already, I have been teaching for quite some time, and I really hope that all of you achieve whatever you want to achieve your dream very soon. If you stay tight, trust me, you can achieve it. Whether you are planning for cracking the JEE this very next year 2021, or the year after that, or even the year after that, do not worry. We are there for you. Right now we are trying and complete every single major topic which is there in JEE, and slowly we'll be through the major portion of JEE, and that's where our first leg will probably end, and then we'll start with even more advanced preparations. Do not worry, just sit back and hold tight. That's all. Welcome aboard, welcome aboard. Hi Saurabh, hi Prija, hello Santosh, hello Jaswant. Jaswant, you're going to give the exam in all the years of this century. Okay. Well, welcome. So in case you have not yet subscribed, please go and hit the subscribe button. It is going to cost you how many rupees? 0 rupees. So go ahead and please click the subscribe button now, or else you'll be missing out on all the notifications. And do not forget to like. Come on. You have to give me that energy. If you don't give me likes, I will not get that energy. Come on. Go hit that like button, or else I'll not get that energy. Yes. And if you have any questions, please put it in the comments. I have been patient enough to respond to almost all your comments, not in the live chat, but in the comments section, which is below the video. Yes, below the description box. So after the lecture is over, if you have some doubts, just post it over there. I'll definitely try and answer it. Well, Navami, thank you. Hi Vikash, welcome. Hello Anumit. Okay, and do not forget to also share our channel with your friends. And today we are going to discuss derivatives in kinematics, which is a very, very important concept. It's a slightly difficult concept. That's why I said expect some turbulence today. And if you follow me carefully till the end, trust me, you will sail through very safely and you will feel very comfortable. Okay, so I hope you can see what's the next chapter too. It's all there over here. This is the schedule of this week. Do not worry, by the end of this week, we'll put up the schedule for the week ahead. Rahul, I'm not ignoring you. I'm there. Okay. So, hello, Mercedes. Welcome. Okay, so let's begin. Are you guys ready to start? Yes? Come on. Let me know in the chat box. I'm reading all your chats. Let me know. Are you guys ready for starting the lecture now? I'm going to come up with a quiz. Let's see who gets it first. Josh is at the peak. Okay, very well. Let's begin. Here is your question on your screen. What is the average velocity for the first 4 seconds of the motion? Average. I have taught you what average velocity is. This is position versus time graph. You can clearly see it is a non-uniform motion, but I feel it is very simple. Chalo, try it out. I'm pretty sure you'll be able to crack it. Come on, try it out. Come on guys, let me know what the answer is. I'm reading all your chats. Yes, Anya, I have started it fast. Come on. I want your answers fast now. Okay, Krito says B. Sankar says C. I do not know who is right. Let's see. Okay, high school says C. Okay, come on. Lot of variations. Nobody is giving a consistent answer. Come on, everybody decide on an answer, yaar. Come on. You have to give a final answer. Okay, let's see who wins. Okay, here is the thing. Let's start discussing the solution. Question is to find the average velocity, right? So let's start. Now, remember the very definition of average velocity was displacement divided by the time which you take. And what was displacement? It was nothing but the final minus initial position. That was what displacement was. Now if you think about it, this is the time axis. Initial means over here. What is the initial position if each box is 1 unit? Think about it. I think 2 corresponds to the initial position. You can very well see that 2 is the initial position. The body or that particle goes up, down, doesn't matter. But eventually, at how many seconds? At 4 seconds. At 4 seconds, what is its position? Just think about it. I believe this is its final position. Just look at that. 4 is its final coordinate. It would have gone ahead, it would have gone back, doesn't matter. So it is 4. So what is final minus initial? Come on. That is displacement. 4 minus 2. That is your displacement. And how much time did it take? It took 4 seconds. So 2 by 4, which is half, which is nothing but 0.5 meters per second. That's the correct answer. How many of you got it? Sincerely tell me, how many of you got it? That's the correct answer. I hope everybody understood how to get this correct answer. Everyone, did you get it? Understood how to get it? Very good. Don't worry if you did not get it. Now I hope you got it, how to solve and get to the correct answer. Great. Now let's move on. So the correct answer was 0.5 meters per second. Same thing what I just told you. Now let's talk about instantaneous velocity, because that's what we are going to deal with today. So pay attention carefully, guys. Pay attention to whatever I'm saying. If you listen to each and every word what I say till the end, you will understand what derivatives is and you will get to some level which is better than what you are now. Now, when I talk about average velocity, what I need is, I need my initial position just like in the previous graph. I need my final position and I also need my time interval. But instantaneous velocity means velocity at that very instant, that time interval must be very small. So let's try to first approach derivatives and rate of change, etc. graphically, and then we'll go to the formulas and the analytical or the mathematical methods. Because graphically first it's easy to understand, and once you understand that, then it becomes easy to look at the formulas. So just imagine that there is a particle which moves along the number line. Remember, this is the graph. Recollect my first session, I had told you one pandu, imagine on a number line, and that pandu on that number line will move left, right, doesn't matter. Alright, and it moves depending on this graph. Like you can see, the coordinate, x coordinate was initially something, and the x coordinate gradually increases, but it is not increasing at the same rate because this is not a straight line. It's a curved line, so it is increasing or it is changing at a non-uniform rate. Now, I want to know what is the instantaneous velocity. Well, here is the thing. Before going to instantaneous, just imagine if I take a big time interval, if I take a decent amount of time interval, then in this time interval, at this time, this would be my position. At some other time, what is this delta t? It's a time interval, change in time. The delta stands for interval or change. At some other time interval, my position is something else. So I hope you see that this delta x is actually nothing but the displacement, like you can see, in that interval delta t. In this interval, it has moved this much. So if I ask you what is the average velocity, you will quickly tell me, oh yes sir, the average velocity is delta x divided by delta t. This much by this much, just like what we did in the previous question. But what if I want to find instantaneous? What do I need to do? I need to make this interval really small. I need to squeeze this. Squeezing this will make these 2 points come closer. Even this gap will drop. Understand guys, there are some students who are probably seeing derivatives for the first time. So let's be patient on the chat box. I understand some of you have already studied this because you are in 12th standard, but you need to be patient for the 11th standard people as well. Okay, so now when I bring them closer, this becomes closer. So understand, I need to bring them so close that these 2 points virtually become indistinguishable. Only then it is called as instantaneous. What is the smallest time? Think about it. What is the smallest time possible? It's not 0.1 second. It is not 0.01 second. It's not 0.00000 infinite 1 second. It's even smaller than that, but it is not 0. So I have to bring it really close. And when you bring it close, the curviness disappears. Observe it. The curviness gradually disappears. If you zoom onto it, it looks something like this. It's curved. The triangle, it's not exactly a triangle, you can say, but it's having the third side which is slightly curved. The height of that so-called triangle is delta x and the base is delta t. It's not a straight line, please understand. It's not exactly a triangle. This side, the hypotenuse one, is slightly curved because these 2 points are not close yet. I bring them even closer. Let's bring them even closer, such that delta t tends to 0. They two are neighboring points. And when these two come so close, these two lines also come so close that delta x tends to 0. That is what I need. That is what I need for finding instantaneous velocity. And then think about it. How will the triangle become? These are just 2 neighboring points, so close. You just cannot see that. It's just like almost 1 point. And if you zoom onto it, by the way, this diagram is highly exaggerated. If you zoom onto it, you will see a nice small triangle. It's very small. This is just for your visualization. It's just for you to think about it. That triangle, guys, will have that curved line almost become straight because there are 2 very close points, and that height will be the small displacement and the base will be that very small interval, infinitely small. Understand that. It's infinitely small. And when a number tends to 0, understand that when some number, let's say delta t, tends to 0, instead of writing all this, we prefer writing this, dt. So dt is a symbol used for specifying that the time interval is very small. Similarly, if delta x tends to 0, I will prefer writing it as dx. So d of anything is a very small change whose value is not known. What is the difference between delta and d? Let me tell you, because a lot of people have that doubt. So understand, I can say delta x is equal to 0.1 meter, or I can say delta x is equal to 0.2 meters. Yes, I can say that. But I can never say dx is equal to 0.1 or 0.001 meter. No, I cannot say that because nobody knows the value of dx. It's very small, just understand that. It's very small. Nobody can write the value. That's why it's given a special symbol called as d. That's the difference between both of them. Okay, so when these two lines almost become indistinguishable, it looks something like this. It's almost like a line. Think as if you have a line over here, that's it, and you have that point. That point also, guys, think about it, it's not exactly round in shape. That shape of that point is also the shape of that line which is going through it. Because if you had to draw that line, right, when you're passing by that point is not exactly circular. Please understand, a lot of people have this misconception that the shape of a point is round. Wrong. It's wrong. Point does not look round. It's not like that. On this line, that point also has that shape of that line. Understand? And so when you zoom onto it, it looks something like this. This is that point, guys. Understand? This is that point which is over here. Are you guys understanding it? Let me know. Are you guys understanding it? Let me know. I'm reading the chats now. Yes? Are you able to understand why that point is also having the shape of that curve? Yo, very good. Understandable. Very good. Very good, Diya. Very good. Achut, Saurabh. Very good. Narana, Preeti, Krito, Kirti, Anu. Very good. Very good. Very good, Sonal. Okay. Now, here comes the next thing. If you have understood this, you would have also understood that the height of this small triangle will be dx, because it is nothing but delta x tends to 0, and the base of the triangle will be dt. And if I mark an angle theta over here, I hope you also realize that tan theta will be dx by dt. Okay, now tan theta is dx by dt. What will be instantaneous velocity? Think about it. Average velocity was delta x by delta t. So what will be instantaneous velocity? Think about it, guys. What will be instantaneous velocity? It will no longer be delta. It will be d. It will be dx by dt. But I know what dx by dt is. It is nothing but tan theta. That's it. I think I have found out the answer. Oh, ho, ho, ho. Look at this. If I want to find instantaneous velocity, all I need to do is find dx by dt. But the problem is, understand, I neither know the value of dx nor I know the value of dt. This is a very, very weird problem. I don't know the numerator nor I know the denominator. Because for finding average, you knew these two things. Instantaneously, you don't know. What is dx? Does anybody know? No. Dat? No. Nobody knows the value. And you are given the task, find dx by dt. So what we did, we looked at this triangle. We saw dx by dt is tan theta. Okay, so dx by dt is tan theta. Now you'll be like, okay, done, problem solved. No, problem not solved. Think about it. The problem is, how do you know what this theta is? Are you going to zoom onto it using a microscope and measure what is that angle theta? Well, obviously not. So there has to be something else. And what is that something else? Just extend that line over here. You will see that line also gets extended over here. I hope you can see that. If you extend that line straight like that, it becomes tangent to that curve. It becomes a tangent at that point. And when it hits the horizontal axis, it will make the same angle theta. Don't you see that? Yes? Don't you see that? It will make the same angle theta. So, what was our original problem? We wanted to find instantaneous velocity. For finding that, we need to know small displacement, small time. But I don't know the numerator nor the denominator. So what we do? We find the ratio. How do we find the ratio? By finding tan theta. But the problem is I do not know the value of theta. So what we did? We extended that point. It became a tangent, and that tangent hit the horizontal line at the same angle theta. Now, if I'm able to measure this angle theta, that's it, my problem is solved, and measuring this is very easy. I hope this is clear. I hope this is very clear. So, essentially, when you extend that line, right, this extension of that line becomes the tangent to the curve, and that tangent hits the horizontal at the exact same angle as this angle in this small, infinitely small triangle out here. So if I know theta, I will also know tan theta, I will also know the instantaneous velocity. Now I know you want to put it into practice, so let's see how to put it into practice. So here is our conclusion. Listen to me carefully. If you have any random curve and the question says find the value of velocity at any time, so at that time or at that point, what you will do? You'll first draw a tangent. What will you do? First draw a tangent. Then that tangent will hit the horizontal time axis at some angle. You will take that angle and measure it, and you'll find the tan theta of it. The tan theta will give you dx by dt, and we know dx by dt is instantaneous velocity. That's what we'll do. Okay? So, honey, I hope you understood this now. So take a point. I'll just repeat what we did. When the gap was very big, average was delta x by delta t. You make that numerator and denominator small, that triangle becomes such that it almost becomes like a point, and these 2 points come so close that it becomes a straight line. This height becomes small displacement, and this base becomes small time interval, and that small displacement is dx, this small time interval is dt. And since instantaneous velocity will be small displacement by small time, which is dx by dt, hence by trigonometry it should be tan theta. To find the tan theta, what we did, we extended that line. That means it will get extended here, and it will be tangent to that curve. And the moment it becomes tangent, I only have to measure this angle theta, nothing else. My job is done. Don't worry. Now we'll solve a problem so that you will understand it. Don't worry. Let's take up a problem. So just imagine. Just 1 second. Okay, so let's imagine we have a graph of position versus time. Okay, and let's say the curve is something like this, and then I tell you at 2 seconds I want to know what is the instantaneous velocity. Okay, that's the question. Find what is instantaneous velocity at t is equal to 2 seconds. That's the question. What will you do? First, go up and mark a point on the curve. This is the point P on that curve. What will be my next step? Think about it. What should be my next step, guys? Yes, drawing a tangent. So draw a tangent to that curve at that point. So that is the tangent to that point at that curve. Okay. Next thing, what will we do? We will measure this angle. Let's say this angle comes out to be 60 degrees. Example. Hence, what will I say? The velocity at point P, that is at 2 seconds, will be nothing but tan theta. And what is theta, guys? Theta is nothing but 60 degrees. That's it. And what is tan 60? Obviously it is root 3. And what is the value of root 3? Approximately it is 1.7 meters per second. That will be the answer. That's it. We have found out the instantaneous velocity. Graphical method. This is the graphical method. I hope you now understood how to solve the problem. Is this understood? Let me know in the chat box. Yes, most of you I know have given the answer. Very good, very good, very good. Very good, very good. Excellent. So, just imagine. Let me give you a fresh little problem. Oops, 1 second, guys. Just 1 second. Yeah. Now, let me create another problem and let's see what you answer. Okay, just imagine this. Again, I'll draw a graph. This is position, this is time. Okay, And now this time the graph, let's say, goes like this and comes like this. And I tell you, what is the velocity at this point of time? Let's say this time is 3 seconds. We want to find velocity at 3 seconds. We want to find that out. So first thing, what will we do? At 3 seconds, draw a tangent to that curve at that point. Okay? Draw a tangent to that curve. Now when you draw that tangent, it will so happen that it will be, first of all, it will be downwards. Did you understand? It will be downwards, guys. It is not upwards. If I draw a tangent here, yes, it is increasing. The slope, the steepness is positive, but here it is downwards. Understand that. So here, instead of, when you measure this angle which it makes with the horizontal axis, maybe the angle is, example, 135 degrees, example. Because remember, always when you draw the tangent, you measure this angle over here. So if this keeps increasing, you will see when it becomes obtuse, this is the angle that you will measure. Example, it is 135 degrees. So what will be the velocity at 3 seconds, guys? The velocity will be, think about it, it will be tan 135 degrees. And you will learn in trigonometry very soon that tan of 135 degrees is actually minus tan 45. Yes, it is minus tan 45. So you will learn this in trigonometry later on. Those of you who do not know those formulas, do not worry. You will learn that. But understand, it is solvable once you get that trigonometry knowledge. And tan 45 is 1. So the answer is minus 1 meters per second. I hope you are getting the hang of this now. I hope you are getting the hang of this. Right? Graphical method, at least you would have got it in your head. Yes? Very good. I can see all the answers. Excellent, everyone. Saurabh, Jaswant, Lux, Shorbi, Piano, Anu, Yo. Very good. Very good. Very good. Chalo. Let's go to the problem now. Let's see who can get this. When is the instantaneous velocity 0 in this position time graph? Look at it carefully. When do you think out of these 4 options is the instantaneous velocity 0? Each square corresponds to 1 meters in the height and 1 seconds in horizontally. Come on. Think about it. Come on, and reading your answers. Very good. Most of you are getting it correct. Very good. Keep it going. Some of you are giving it wrong. Think again. I will not tell you which one is wrong though right now. Okay. Think about it. Well, I'll tell you now who all are correct. So Venu is correct. Chinmay is correct. Oh, no. Sorry. They are not correct. My bad. Oh yes, sorry. They are correct. Option B. Yes, option B. All those people who said option B or 2 seconds. Yes, they are correct. Option A, C and D are wrong. I'll tell you why. See, it's very simple. What does the question say? The question says that we want the instantaneous velocity to be 0. Okay. If instantaneous velocity should be 0, what does it mean? Guys, since velocity is dx by dt, which is also tan theta, can I not say tan theta should be 0? That means if I draw a tangent, that tangent angle should be 0 degrees. Now think, where will you draw the tangent so that the angle that it makes with the horizontal axis is 0? Will it be here? No. Will it be here? No. Will it be here? Yes. This is parallel to the horizontal line. Here it will make some angle. Here also it will make some angle. So this is that point. Which is this point? Check this out. I think it is 2 seconds. And that's why that's the answer. No problem if you made a mistake. It's okay. No problem, Narayana. It's okay. Fine. Nobody is judging anybody here. We have all come here to learn. If we knew everything, why would we be here? Right? Do not worry. Okay. So essentially at this point, understand guys, if you draw a tangent at this particular point, the tan theta is 0. So that's why the velocity is 0 at this point, which is nothing but 2 seconds. Okay, that is how you solve this particular question. Great, great, amazing, amazing. So let's go to the next question. Let's go to the next question then. Okay, now we did the previous question. Oh, is it option C? Oh, I'm so sorry guys, it was option C. I made a blunder. Sorry guys. It was option C. Thank you for pointing it out. Thank you. Yes, it was at 2 seconds. I thought B option was 2 seconds. I'm so sorry. I'm always facing this side. I don't know what is there on the board. Yes, okay. So the correct answer was 2 seconds and it was option C. Okay, great. Now, let's go to the next question. What is the velocity at 1 second? What is the velocity at 1 second? Come on guys, let's see. Come on guys, let's see. How many of you get it? What is the velocity at 1 seconds? Come on, give the answer. Instead of giving the options, give me the value itself. 0.5102. Okay, lot of people coming up with different values. Many of you are wrong. Think carefully. I'll give you a hint. There is a tangent which is drawn and see carefully through which all points it is going. This is a very tricky question. Think carefully through which all points it is going and then try to measure tan theta by using the definition of tan theta. It is opposite side by adjacent side. Use that definition, you'll get the answer. Come on, try it out. Think carefully. Lot of you are giving the wrong answer, let me tell you that. Lot of you are giving the wrong answer. Okay, Chinmay, very good. क्या बात है, very good, Vijaya. Okay, Prakash, field physics, very good, Kirito. Okay, Rishabh, very good. Tanmay, very good. Arundhati, good. Rashid, Gaurav, finally, you guys are getting it. See guys, what you need to do over here. Understand how to solve this problem. Here, this itself is the tangent, right? This is the tangent. Now the problem is, if I want to measure the velocity at 1 second, what I need to do? I need to measure tan theta, where theta is the angle by the tangent with the time axis, right? With the time axis, whatever angle it makes, that's angle theta. So that angle is here. That's the problem. That angle is here. But no worries. Do not worry. I can measure this angle theta indirectly. How? Look at this point. Look at this point. And what if I draw a triangle over here? If I draw a triangle over here, you will see that this is a straight line and these are two parallel lines. So if this is theta, obviously this would be also theta, correct? This would be also theta, and each block is 1 unit. So what will be the height of this triangle? Obviously 2. What will be the base of this triangle? Obviously 1. So think about it. What will be the value of tan theta? It will be opposite side divided by adjacent side, which is nothing but 2/1. Hence the correct answer is 2 meters per second. Did you guys understand it? What a nice trick it involved. Isn't it cool? So the correct answer is option D. Yes. Amazing questions. Are you guys having fun? Are you guys learning, understanding and having fun? Yeah? Very good. Yes, Anumit, velocity is tan theta. Very good, Arundhati, Ayush. Don't be sad. Come on, cheer up. Don't worry, you will learn. Yo, very good, Chinmay. Very good, Videsh. Bahut hi badhiya. Very good, Sonal. Naomi, very good. Obviously easy, it seems. Okay, let's go to the next point. Okay, now let me talk more about derivatives and differentiation. What we have been doing, right? This thing, V is dx by dt. while pronouncing, now I'm going to teach you how to call all these different names. This is read as dx by dt. You can also call it as rate of change of x with respect to time. That's another way of calling the same expression. Or you can also call it as derivative. Derivative is the word of x again with respect to time, or you can also call it as differentiation with respect of x again with respect to time. All the same things. Differentiation, derivatives, rate of change, how quick is it moving with respect to time. All these things mean the same thing. Dx by dt, all these things mean the same thing. Understand that. So understand, if I tell you dp by dt, where p represents momentum, okay, p represents momentum, what will I call this as? Rate of change of momentum. If I write it as dA by dt, what will I call it as? Rate, where A represents, for example, area, I'll call it as rate of change of area. If I write it as V by dt, where V represents velocity, I'll call it as rate of change of velocity. How fast velocity changes with time, how fast area changes with time, how fast momentum changes with time. Understand that. So basically what derivative gives us is the rate of change of a quantity. Understand that. And that's one way of looking at it. And there is this mathematical way. We have been seeing x versus time, right? So instead of x versus time, if I had graph of y versus x, and I had some random graph, doesn't matter, some random graph, and let's say I draw a tangent somewhere at some point, right? This is a tangent and it makes angle theta. Now when I say dy by dx, come on, type it out. What do you call dy by dx? It is derivative of, come on, derivative of, come on, what do you call dy by dx? Come on, write it out in words. Derivative of y with represent, see, y and x are some variables, Krito, some variables. Y with respect to x, y is some quantity, x is some quantity, we don't care. It could change, like in the previous thing, y-axis was position, x-axis was time. These are some variables, alphabets at the end of the day. Very good. Derivative of y with respect to x, derivative or differentiation of y with respect to x. And what will it be equal to? Tan theta. And this tan theta is also called as the slope of the tangent. This is the slope of the tangent at point P. Understand that. This is the slope of the tangent at that point P. In general, for any y versus x graph, it is valid every time. Derivative of y with respect to x, dy by dx is slope of the tangent. Come on, say it 100 times in your mind. Derivative of y with respect to x is tan theta, which is the slope of the tangent. Keep on saying it. You will get it. It should get in your head now. Very good. So we have seen all this, dy by dx. I've just kept pointers. These slides are just like pointers which are there in your slide. So after the class is over, some of you are asking, sir, whatever you write, I want it as notes. So don't worry, I have kept it as slides. Okay, so do not worry. Okay, great. Now we have seen the graphical way. Let's go the other way and let's see, what if I do not know the graph? What if? Yes, field physics, I'll pray for you, don't worry. I'll pray for you, you will get well soon, don't worry, stay positive. Mood wise, but become negative corona wise. Yes, please get well soon, field physics. Okay, we'll all pray for you, don't worry. Okay, now what if, guys, what if you do not know how the graph looks like? What if you cannot draw the tangent accurately because there might be some human error? What if that angle is not that great? What if it is tan of some 69 degrees? How will you do that? Correct? So all these are problems which you will face in graphical method. So graphical method is good if angles are known. If you can draw the tangent very easily, and if you know the angles very nicely, yeah, you can calculate it by some means. But if you do not know the angles, you cannot draw the graph. And if an equation is given, so imagine an equation is given. So first you need to draw the graph, or then you need to draw the tangent, or then you need to measure the angle, or then you need to measure the tan of theta. Isn't it such a lengthy process? What if I gave you a magic wand, and with this magic wand, you don't have to draw the graph, you don't have to draw the tangent, you don't have to measure the angle, you don't have to measure the tan theta? What will you do? Yes, let's see what that method is. Example, let's take this. What if x is t cube? What if x is t cube? Now, see guys, the whole idea is that position changes with time. And I don't even know how that graph looks like. I don't care. But there are formulas which are there for it, and those formulas will be derived for you in your 12th standard. But we are studying physics, right? We are not studying maths exactly. So do not worry. We are just going to borrow from maths. I'm just going to borrow from Shimon sir. Please give me that formula and we're going to use that. That's all. So there is a formula for this. And what is the formula? Let me tell you that. So here is the thing. Understand? Just follow me carefully now. If I want to find dy by dx, where y is basically x raised to n. What is n? N is any real number. N is any real number. 1, -1, 2, √2, anything, doesn't matter. Whatever it is. Okay, so what you can do is understand the formula goes like this: d by dx. What is the value of y? Check this out. X raised to n. X raised to n. The formula which you are going to learn next year, right? You are going to learn how to get to this. We are just borrowing it. I'm going to time travel and just borrow it from 12th standard. Just think of it that way. The formula is whatever is the power, here it is n, that n comes outside into the variable raised to, the power should be reduced by 1. That's the formula. That's how it is. That's it. Nx raised to n minus 1. What is this telling me? It is telling me the rate of change of x raised to n with respect to x, or the rate of change of y with respect to x is nx raised to 1. If the function looks like this, what if the function looks like sin x, cos x, tan x, etc.? I'll come to that. Wait a minute. But for now, just understand when y changes with x as given over here, y is x raised to n, then derivative of y with respect to x is the power comes outside and the power of x reduces by 1. Remember this now. Write it down 10 times in your book right now. Come on, write it down. We're going to use this. Write it down 10 times, not in the chat. Write it in your notebooks. Write it in your rough paper somewhere. Come on. Okay, very good. Now we are coming to example. Yes, don't worry. I'm not running away. Yes, we are going to come to an example. Okay, so don't worry. I kept the slide for your reference so that when you download it as a PDF, it's all there. So derivative of x raised to n with respect to x is nx raised to n minus 1. Remember that. Power outside and the power of x on the top reduces. So let's see, how do I use this? How do I use this? Let's see that. Okay. Let's take the same example. Remember just some time back I was telling you, what if x was t cube? So let's use that same example and let's see what do we get. So here we go. Okay. So find the velocity when time is 2 seconds if the motion is given by x is t cube. Now this x is t cube means what? You give me the time, I'll tell you the position. But you give me the time, it does not give you the velocity. It's very bad. You tell the time, I'll tell you the position where it is, but I won't tell you what the velocity is. To find the velocity, I have to use derivatives. Let's see how do you use that. Because the question says find velocity, let's think what is the definition of velocity. Instantaneous. because it says at 2 seconds, that is instantaneous. So the definition of instantaneous velocity, guys, is dx by dt. Great. What now? Substitute the value of x. What is the value of x? Think about it. The value of x is t cube. Okay, great. It is t cube. Now what do I do? Use the formula. Didn't I just give you? dx raised to n by dx. Derivative of x raised to n. This was y, remember some time back. Is nothing but nx raised to n minus 1. That was the formula. That's it. Use it over here. Instead of x you have t. Instead of n you have 3. Use it. That 3 comes outside and that power of t reduces and it will become 3 minus 1. What is 3 minus 1? 2. Very good. That's it. That is the answer. But not yet. We have to find at 2 seconds. So that means what will you do? You will put the value of time as 2 seconds. So substitute v as 2 seconds. What will you get? 3 into 2 square. 2 square is 4. 4 into 3, 12. So 12 meters per second is the answer. That's it. Did I draw graphs? Did I measure angle? Did I draw tangent? Did I? Did I? What did I use? I just use formula. That's it. Just use the formula. That's it. That's how simple derivatives is. So let's start solving more problems. Amazing? Are you guys amazed? Amazing. Amazing. Let's start solving problems. So you get a hang of it because I have put very good problems in the assignment for you to solve, which I'll be discussing tomorrow morning, tomorrow afternoon around 12 o'clock. Yeah. So let's start solving some more problems so that you get a hang of it. Now, what if the function is not x raised to n? What if it is something else? So don't worry. I have given you all the formulas over here. Derivative of x raised to n with respect to x is nx raised to n minus 1. Write it down right now at least 10 times. Come on, write it down. Let it get into your head. Derivative of, and while you are writing it, say it. Derivative of x raised to n with respect to x is nx raised to n minus 1. Second formula, derivative of sin x with respect to x is cos x. Write it down 10 times. Derivative of cos x with respect to x is minus sin x. Derivative of tan x with respect to x is sec square x. Derivative of constant with respect to x is 0. This you don't have to by heart. This you don't have to by heart. Why you don't have to by heart? Because come on, constant. How will constant change? Constant won't change, right? Think about it. If I draw a graph, right, of a constant, how will it look like? Like this. So what will theta be? 0. So what will tan theta be? 0. So what will derivative of a constant be? It will be 0. Constant doesn't change. Remember, constant is a constant. It doesn't change. So rate of change of constant is 0. Understand that. That's why the last answer, no need to by heart. It is common sense. But remember these basic formulas. There are more you will learn in 12th. But for now, this is enough. More than enough. Okay. I hope you have written it down. Okay. Yeah, in maths there is a big list, huge list. For now, in physics we'll just take care of these few formulas. That's enough for us. We are good. Okay. Chalo, let's go ahead. Let's go ahead. Yo. Okay. I hope you have written all these things at least few times. Let it get into your head. Let's start solving some problems. Okay. Let's start solving some problems, guys. Now, imagine. Arey yaar. Okay, imagine I tell you x is equal to sine of t. Example, I tell you x is sine of t, and I tell you find the velocity at t is equal to 3 seconds. This is the question. What will I do? Let's see. Because we have been asked find velocity, here is what I'm going to do. Velocity is dx by dt. But what is x over here? Think about it. X is nothing but sine t. Correct? It's sine t. And I just made you write down all the formulas. Look over there and check it out. What is derivative of sine t? You will get it. What is derivative of sine t? Cos t. Correct. It is cos t. So what will you do now? Don't stop over there. Put the value of time as 3. So it is basically cos of 3. That's your final answer. Isn't it simple? Isn't it simple? Tell me. Isn't it simple? Very good. Look at that. All of you are writing the answers, guys. I'm so happy, so glad that you guys are understanding and you are, yes, very good, very good, very good. Let's see the rules and then let's do some amazing problems. Let's see some rules. Very easy rules. First, multiplying with a constant rule. Very easy rule. Example, I tell you, x is equal to, I don't know, maybe cos of t, and there is 4 over here. X is 4 cos t. Then if I want to find dx by dt, then it will be d by dt of 4 cos t, right? When there is a constant getting multiplied with your usual formulas, that constant can come outside that derivative. So it will become 4 times d by dt of cos t. That's it. And what is the derivative of cos t? I just gave you. What is it? What is the derivative of cos t? No, it is not sin t. It is minus sin t. Be careful. I have put that minus sign in case you have missed it. So it is 4 into minus sin t. Derivative of sine is cos. Derivative of cos is minus sine. Be careful. So the final answer is minus 4 sin t. Please understand that. Okay, so basically the constant just comes outside. Very easy. That's your first rule. Isn't it easy? Let's go to the next rule then. If you want, I'll give you one more example. It's very easy, guys. What if y is nothing but, let's say 7x square, and I want to find dy by dx. Don't worry about that constant. Just put that 7 outside and just write it as derivative of just x square. And what is the derivative of x square? Try to recollect. This is of the form x raised to n. This is nothing but n. So just take that n outside. It will become 2, and derivative of this one, that 2 should become less by 1 unit. So it will become 1. So it will become 7 2s are 14. It will become 14x. That's the answer. I hope this is clear. Very good. Very good. Chalo, let's go to the next problem then. We are going on rapid fire mode now because you guys are all pumped up and you guys are understanding it. Very good. So multiplying of a constant is done. If there is a constant in that function, that constant just comes outside when you take the derivative. I've put the rule for you for your understanding, for your revision, right? So it's there on the in the PDF, which will be available for download after the session. So this rule is there. Next, addition, subtraction. This is easy. Let's do this. Addition and subtraction rule. Imagine x is equal to x square plus sine of x. And I ask you, once again, y is equal to x square plus sine of x. Then if I ask you what is dy by dx, very simple, guys. When you have two functions which are added or subtracted, just add the derivatives separately. So it will be d by dx of x square plus d by dx of sine of x. So what is the derivative of x square? Recollect, this is nothing but n. This is n. So that 2 comes outside and this 2 becomes 1 in the power of x, right? Plus sine x's derivative is cos x. So that is the answer, 2x plus cos x. Very good. I can see so many answers being written. I'm so proud of you guys. Excellent, guys. Excellent. Very good. Let's try this once more. Let's try this once more. What if x is equal to 3t minus sine t? 3t minus 5 sine t, let's say. 3t minus 5 sine t. Okay? And I want to find dx by dt. Okay, let's do this. So 3 is a constant. Remember, 3 is a constant. So anyways, I'll write that step. It is 3t, this derivative, minus derivative of 5 sine t. So what will happen? That 3 first of all comes outside. And if you're wondering what should I do over here, don't worry, guys. There is a very simple trick. This is 3t, right? Write it as 3t raised to 1. Now that becomes very easy. That is that n over there. N. X raised to n's formula, that is that n. So that 1 comes outside and t raised to 1 minus 1. What is 1 minus 1? 0. So it will become t raised to 0 minus, what is this? phi going to do? It is going to come outside, so it will become 5. Derivative of sine t, I just told you, what is it? It is cos t. That is the answer. So I'll simplify it. T raised to 0, guys, is 1. So it will become 3 minus 5 cos t. That's it. That is the derivative. Very good. Very good. Excellent. Excellent. Excellent students. Very good, Shankar, Anumeet, Kulraj, Vijay, Anu, Neha. Very good, B. Gayatri, Krito. Very good. Very good. Very good, Sonal. Harshvardhan will start it soon. Don't worry. Keep a tab. Okay. Very good. Let's go to the next rule then. So whenever you have addition, subtraction, just individually add and subtract their individual derivatives. That's the simple rule. Very good. Very good. Now we put the comments in the chat box. Later on in the comment box, I'll be reading it. Don't worry. Now, next rule, product rule. Product rule, guys, very easy. I'll tell you what to do. Imagine you have y is equal to x cube into sine x. Just imagine. Two functions getting multiplied. Yes. Then what to do? Remember it this way. These are the two functions that I have, correct? This is my first function and this one is my second function, and these two are multiplied. What you need to do? Take the first function. What is the first function? X cube. Write it as it is. Don't worry. Take the second function and take the derivative of the second function. What is derivative of sine x? What is the derivative of sine x, guys? Come on. If you don't understand it, okay, let me write it like this. Derivative of sine x. And just put it over here. X cube into, what is derivative of sine x? It is cos x. Very good. Plus, write down the second function now. What is the second function? Sine x. And use the first function's derivative. So derivative of x cube. That's it. So that will become sine x into derivative of x cube is 3. 3 comes outside because remember this is n. That's it. So 3 minus 1 is 2. That is the answer. Is it simple? Is it simple now? See, look at this. Everyone understood? So first function into second function's derivative plus second function into first function's derivative. Very good. Very good. Very good. Very good, Gayatri, Prija, Neha, Tanmay. Very good. Very good, Shankar. Very good. Very good, Sonal. Amazing. Superb. Let's go ahead. So that was product rule. If you have multiplication of two things, then first function into second's derivative plus second function into first function's derivative. Right? Very good. Now what about division? Let's see this. Division, division, division. Let's see. Okay, 1 second. Okay, just imagine you have y is equal to tan of x. Now you'll be like, sir, where is the division over here? I'm going to get that division now. So tan of x is nothing but sine of x divided by cos of x. So you can see that again you have two functions. This is the first function. This is the denominator function, second function. So what you need to do? If I want to find dy by dx, it is the denominator, the bottom function, second function, cos x into the numerator function's derivative. So d by dx of sine of x minus the first function or the numerator function, sine x, into derivative of the denominator or the second function. So d by dx of cos of x, the whole thing divided by the denominator's square. So cos square x. So just understand this. This is the second function. Oh, just 1 second. This is the second function into first function's derivative, right? Into first function into second function's derivative upon the denominator's square. That's what has happened. Okay, great. So let's see what do we get as the answer. Cos of x. What is the derivative of sine of x? Come on, type it out. Sine of x, derivative. Come on, what is it? What is it? What is it? Derivative of sine of x. Come on, tell me. Derivative of sine of x is cos of x only. correct? Very good. Minus sine of x into derivative of cos of x is minus sine x. Interesting. Divided by cos square x. Now this is cos square x. This minus minus becomes plus. So it will become cos square x minus sine square x divided by, what is it? Cos square x, guys. I hope you guys are understanding it. Very good. Oh, sorry, this is plus, my bad. Plus, because this minus and minus became plus, my bad. So what is sine square plus cos square? What is sine square plus cos square? Think about it. This term, sine square plus cos square, it's an identity. It is 1. Very good. So if you have understood it, then nothing else is there. 1 by cos square. Yes, 1 by cos square, guys, is nothing but sec square x. Very good. So that is the final answer. Derivative of tan x is sec square x using division rule. Amazing, isn't it? Amazing. We got it. So cool. So cool this is. Very good, very good, very good. I can see so many people answering this. Look at that. Okay, so that is division rule. If you have one function divided by the other function, the denominator comes here into derivative of the numerator minus numerator into derivative of the denominator divided by denominator square. If you write it few times, it will get over. Thank you, Devars, for your concern. I'm so glad you think about me, guys. Thank you, Krito. Jyoti, I will tell you everything. Gayatri, I'll tell you everything. Don't worry. Okay, guys, come on. Okay. Yes, Saurabh, I'm teaching more of maths now, but this is needed for physics. Okay. Now, what about instantaneous acceleration, guys? What is acceleration? Rate of change of velocity. Now, what did I tell you rate of change of any quantity is? D by dt, right? D by d. So, dv by dt. Very good, Devars. No, not integration, Prija. Think again. Very good, Jaswant. Chini, I'll be telling you everything later on, but first let's concentrate. Very good, Jaswant. So, if velocity, look at the change. It is not position. Look at this carefully. It's not position, it's velocity. If it is velocity versus time and the velocity changes randomly, then when you take a small time interval, then you get a very small change in velocity. That small change in velocity, I will call it as dv. And that small change in time, I will call it as dt. So, that small change in velocity at that point, remember this triangle? Remember this triangle I just showed you some time back? So, at that point, that red curve will almost become like a line. This height will correspond to this gap over here between these two lines, which is the small change in velocity, and this two lines gap will be over here, which is very small time interval. That change in velocity upon time taken will be instantaneous acceleration. So it will be dv by dt. Understand that. So remember one thing, just like average acceleration was delta v by delta t, change in velocity upon time interval, instantaneous acceleration or just acceleration will be, instead of delta, you will have dv by dt. So understand, it will be also equal to tan theta, but this theta, be careful, this theta is the angle made by the tangent, not in position time, in velocity time. Yes, not in position time. So please keep that in mind, else you'll get a wrong answer. Just any slope doesn't give you acceleration or velocity. You have to always check what is there here and what is there here. If it is position time, the slope will give you velocity. If it is velocity time, the slope will give you acceleration. If it is acceleration time, the slope will give you, don't worry, it's just rate of change of acceleration. That's all. Okay, it's just rate of change of acceleration. Okay, so that was instantaneous acceleration. Remember that. Very good, very good. Now we have done this. Oh, wait. Now let me do a very interesting problem for you. And oops, 1 second, guys. 1 second, this. It's playing games with me. I need to be very gentle. Okay, chalo, let's do this. Okay, are you guys ready for the last problem today? Are you guys still enthused about this? Come on guys, let me know in the chat box. Last problem coming up right now. Very good. Yes, I know it's very sensitive. Yo, very good. Let's do this. Come on. Say yo or else I will not be energetic. Come on, everybody put up. Everybody comment. Are you guys enthused for the last problem for today? Very good. And that's it guys. After this, you will feel confident about derivatives. Let's look at it. Let's look at it. What is it? Say for example, I tell you, x is equal to something, maybe 7t cube plus 3. Okay? That is what x is. Now, imagine I want to find velocity. How do I find velocity if x is given? Just think about it. Velocity is the rate of change of x with respect to time. So, what do? Put d by dt. Now, there are many terms. In fact, two terms over here. One term here, one term here. And remember the addition rule? Separate them out. So, it will be derivative of 7t cube plus derivative of 3. Okay. Now 7 can come outside, remember? So it will become 7 and you just have t cube inside. Remember this is x raised to n's formula. So t cube's derivative, what will it be? Think about it. It will be 3t square, correct? It will be 3t square. Great. It will be 3t square, 3 comes outside, 3 reduces by 1. Okay, very good. Plus derivative of 3. Oh, it's 0. It's a constant. Remember, it's a constant. Very good. So, therefore, velocity will become how much? 7 3s are 21. 21t square. Great. Now, interesting thing. What if I want to find acceleration? What is acceleration? Well, acceleration is dv by dt. Okay, do I know v? Yes. So, let's put that. So, 21 will come outside anyways, but anyway, let me put it step by step. So it will be 21t square's derivative. This 21 will come outside. So this will become 21 into t square's derivative, where this 2 is n. What will it become? 2 into t raised to 2 minus 1 is 1. 21 into 2, 42t. That's it. That's the acceleration. That's the acceleration. So velocity was found by taking the derivative of x. Acceleration was found by taking the derivative of velocity. So, isn't acceleration the double derivative of x? Isn't acceleration the double derivative of x? So easy. Yes, that's what it is. Just like, understand guys, just like just like velocity was dx by dt, acceleration was derivative of velocity with respect to time. I can write acceleration as second derivative of x or double derivative of x with respect to time. This is the notation for that. This is a symbol. Please do not say, sir, it's d square, there is d, let me cancel this d and this 2 and all that. No, 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 no. Please don't do such stupid things. Okay? Don't do that. It's a symbol. Just like this was a symbol, and you do not do the foolish mistake of cancelling d. So that way also, do not cancel this. This is d square v by dt square. Second derivative. That's what it means. Just taking derivative of derivative. What will be triple derivative? Derivative of a derivative of a derivative. What will be fourth derivative? Taking derivative. Come on guys. 1, 2, 3. Take it. That's it. You'll get the answer. Yes. That's all. Derivatives of derivatives is called the second derivative or third derivative and all that. That's how the symbol is. So d square y by dx square is derivative of a derivative. That's what it means. If you have understood this much also, no, I'll be very happy, because now the next level of understanding you will get by solving those problems which I put in the description box. Yes, yes, you can find the end derivative, Saurabh. Description box. Yes. Check out the description box, and I have placed amazing problems. I want you to solve it and attend the class tomorrow, guys, at 12 o'clock, where I'll be discussing. It's going to be a recorded session, no doubt, but I have thought about every possible aspect and said whatever I have to, so that you will understand everything. Yes, I understand. I know you are waiting for every class of mine. No problem. Very good. So the drills are present below. Do not forget that. And tomorrow at 7 o'clock, we are going to do relative motion in 1D. Yes, only 1D. 1D relative. And such amazing problems I have planned. Syllabus will be over very soon. Revant, by another 2-3 months, we are planning to cover all the major chapters. Yes? Yes, Deepak. Today's drill was also recorded. All the drills will be 99% recorded. Because I have to plan for these lectures, guys. It takes a lot of time. And by the way, please join the Telegram group. In case you have not joined it yet, please go ahead, join it, so that you get all the updates, the messages, notifications, the PDFs of today's session, everything in the Telegram group. Do not forget that. Okay, so bye-bye. Do not forget to like, share, and subscribe. Else I won't like it. Come on, guys. You have to like, share, and subscribe. Go ahead and like, share, and subscribe. Thank you very much. Thank you, everyone. Good night. Bye-bye. See you. Take care. Stay safe. Keep washing your hands. Stay at home. Bye-bye, guys. Take care. Take care. Take care. See you.